Having given the keynote presentation yesterday, I thought I'd better sort of distinguish between the two. I'm sure you don't want to hear the same thing again. So that's why, I've decided to be a little bit more casual about it, and I also, I'm going to deal more with some of the practical realities that we as Neotel are facing with convergence. The starting point for the discussion is what is convergence? And I think, no doubt in a session like this, you've probably heard 15 or 20 different definitions of convergence. For us, there are multiple dimensions to that convergence. And I just wanted to touch on three broad dimensions of convergence. They're all relevant to what we do. Firstly, voice and data. So the coming together of voice and data. It's safe to say that that's probably happened already, but it hasn't necessarily happened across all networks, and it hasn't happened across all operators. Then the coming together of fixed and mobile. Fixed and mobile almost certainly hasn't converged in the real sense, although there's a lot of potential for convergence of fixed and mobile. And then content and distribution. I think this is important also in the context of South Africa, and I'll touch a little bit on the EC Act, the Electronic Communications Act in South Africa, which has tried to deal with this whole content and distribution, broadcasting and telecommunications convergence. This is a picture that I had put up on the presentation yesterday, but I can now explain the picture to you. What you're looking at is those three dimensions of convergence. Voice data and internet for us as Neotel is converged already. Why do I distinguish between data and internet? I often get that question. What we're talking about here is three dimensions of kinds of services that get delivered to, say, an enterprise customer. Voice, I think everybody recognizes. Voice is when you pick up the phone and you call somebody anywhere on the world. Internet, I think everybody understands. It's when you connect to that global phenomenon we call the internet. But what we've used the term data here to mean is enterprise data. This is the VPNs, the virtual network, the network that connects, for example, a business head office to its branches. Those three things used to be quite distinct. They have literally converged in a physical network sense. The second thing is the fixed mobile dimension. Now in South Africa, with the legislation that we have, and particularly with the license that we have as Neotel, which is a fixed mobile license, what's happened in effect is not really a convergence of those two poles, but really some kind of blurring of the boundary. So we operate a little bit across that boundary between fixed and mobile. And because of the licensing in South Africa, as you'll see, that will change over time. And then finally, in the services to content dimension, we are a network provider. We're licensed as such. In South Africa, that's called an ECNS, or Electronic Communications Network Services Provider nowadays. We have a services license. We're an ECS, or an Electronic Communications Services licensing. We're not actually a content provider. There's a whole lot of content out there. Some of it is IT applications, some of it is video, some of it is just the internet generally. But we see ourselves playing into that space, but not necessarily being the provider of the content. So that's as we see convergence. As Neotel, we focus ourselves towards two separate market segments, and we're treating them somewhat differently. So we're focusing on the enterprise market as well as on the consumer market, but on a common network as far as possible. That's important as well. There's no good having convergence of enterprises in one network and convergence of consumers in another network, and you can't actually leverage the assets. We're focusing also towards specific geographies, so this will give you a sense of where we're actually launching services. But if you can see, I think it's a little bit dim in the background there, you can see our backbone network that links those major centers. A little bit about Neotel, because this will give you a bit of context. We were established and licensed actually at the end of 2005. The name Neotel comes a little bit later, but during 2006 we launched wholesale services off the backbone of our network. We got access to a national 8,000 kilometer long distance network. We bought up fiber, which was built more or less for this purpose within the major metros, and importantly we got ourselves a 2 billion rand debt to be able to start deploying. In the course of 2007, we've done a whole lot of things which really culminated in us launching into the market. But I'll just list a few things because these are key to what you need in order to be able to actually build converged networks. We completed the backbone network, which was and I'll come back to the NGN model shortly, and made the first call across it. We obtained 800 megahertz CDMA spectrum, and I'll come to how that fits into the convergence now. We've made an acquisition which is also a quick and easy way to get into markets. We've acquired what's called Transtel Telecoms from one of our parent companies, which has given us scale, given us lots of staff, lots of places. We've been adding to that network over an extended period. And from that, we then started building out to customers. And just to give you a list of some of the customers, CETA, the state IT agency in South Africa, Tenet, which is all of the universities in South Africa. We've got a partnership with CCOM, which is the East African cable that's being built. And around about that point, we decided we would officially launch into the market with our converged services, which I'll show you now. And that happened in November last year. As we speak, we are a couple of days away from the official launch of our consumer services, also converged, but slightly different. Now I want to get back to the theory. So why all this convergence? I mean, there's convergence in the sense that was discussed yesterday about squeezing as much as you can out of the infrastructure as possible. But there must be something underlying that. What makes it physically possible? What's made it physically possible is the internet. 20 years ago, there were perfectly good protocols for delivering voice and data. There were perfectly good networks for delivering voice and data. What happened is that those got swept aside by the phenomenon that is the internet. The IP protocol, the internet protocol, isn't dominant because it's good. It's dominant because basically it got driven by web, by email, by all of the services that come out of the internet. The internet is not really a very robust network. It's not in fact, or it's not a very reliable network. It's a very robust, resilient network. The internet was built to withstand a nuclear war, which it does pretty well, although nobody's ever tried us. But the basic architecture of the internet is about getting the packets through, and if they don't get through, that's just too bad. But if one node fails, you can get through on another node. That's not how you build voice networks. It's not how you build reliable data networks. So what's happened since then has, since the explosion of the internet that's created this convergent platform that we all want to use, is basically trying to take all the principles that we need to deliver reliable services and to carry them over IP, which is really not designed for it. And what happens in practice when you go and build an organization, as we've done, is you employ people who come from a conventional telecommunications background. We call them bellheads. They know about voice. They know about reliability. They know about real time. They know about networks that always work. They know about guaranteed services. They know all about this PSTN that they came from. They know what carrier grade means. They know what availability means, right down to 5 nines. And they know all about those things, but if you look right at the bottom, there's a small problem. That today is very expensive. It's very expensive for 2 reasons. One is it costs a lot of money to build that kind of network, but more importantly, the internet and the IP protocol has swept that aside in terms of volumes and capability. On the other side, you employ netheads, and I think you're all familiar with them. These are the guys who run around and tell you that your LAN can do anything, and that you should throw away your PABX, and you should throw away all that reliable infrastructure, because basically the network will do everything. There's only one small problem, it doesn't. Basically the internet was started out as a best effort network. So what do we have to do? We have to try and marry these two. The interesting thing about the network guys is in many cases they're right that it's simple. It is simple when you plug it all together, and it's cheap, but it's missing that essential component that we call quality of service. Just to stop there for a second, so what we need to do is not only bring together these two halves of the puzzle, we also need to bring together the thinking and the people that go into making that work, and that's quite difficult. It normally involves locking the voice, the data and the transmission and IP guys all in one room together and knocking their heads together until they agree how to put the network together. So how does one do this? How one does this in the network is by taking the IP protocol and adding layers of quality of service to it. When you're able to add those layers of quality of service, we can take some of the best of the left-hand side and combine it with the best of the right-hand side. So what do we want? We want the cheapness of the right-hand side combined with the reliability of the left-hand side. We want the real-time capability of the left-hand side combined with the connectionless and rooted architecture of the right-hand side. I want to be able to lose nodes in my network, but not lose my voice calls in the process. Having said that, what is actually happening in the market? What's happening in practice is that this dominance of IP has basically started to eat up the PSTN. And if you look at the trends in Europe, and I think Africa is following this, particularly South Africa, we're seeing the trends in this direction, is the voice over IP, which is if you like, the simplest of the services that we're trying to deliver, is basically now taking over from conventional switch to PSTN voice. And it's an economic effect. It's not because the technology is better. In fact, in many cases, as it's indicated, the technology is worse. What's also happened as a result of that is the money you can extract for a voice service is being replaced or being eaten up by the fact that your customer perceives the voice service just to be an application. And if you charge too much for your voice service, he's going to go and get Skype or something else and use his own voice service. You can no longer charge for voice the way you used to. You now have to start charging for the underlying data, the data capability. There are plenty of models to look at this, but if you look at the projections, this is a BMIT projection, what it's telling us is that even if you think you're a voice operator, you're actually basically a data operator. You've got to find a way to maximize the revenues across that data infrastructure. You've got to maximize the number of services across it. So our basic model as Neotel for an enterprise customer is we take where they used to get a voice service from, say, one provider, very often was particularly incumbent. They might get a data network in South Africa. Often they'd get their data services from another provider, a value-added network service provider, and perhaps internet from a third provider. And even if they were getting those from one provider, often they were getting them from physically separate networks. And the example that we give, if you look at the physical connection, is that typically what would happen in South Africa in the past is that 3 different trucks would arrive with different technicians connecting different wires, and you'd effectively be buying 3 different services. Our model is to flatten that all out and deliver a single next-generation network service over a single fiber. When I say single fiber, if the customer wants reliability, we do give him 2. So there's redundancy. 1 connection, 1 provider, multiple future-proof services. So this is our model, and those are the services in case anybody's interested in what they actually are. The underlying base infrastructure still has to be there. So we have a couple of services we call Neolink and Neolink Global, which are underlying transmission services. But our package of services, our enterprise multiplier, if you like, that we deliver to enterprises, is all enabled by that IP infrastructure. There's still services. We still charge money for the different services, the voice, the VPN services, the internet services, but they're all carried over that single IP infrastructure. That for us is physical network convergence. Okay. I'm going to just quickly go through the 6 mobile convergence. And the convergence of fixed and mobile is something which can be one of many things. It can be bundling of products at a marketing level. It can be the convergence of the operators. And we've seen that sort of happening in some markets. It can be the convergence of the service. Or it can actually be the physical convergence of the network. And importantly, at the customer's end, convergence of the device. The way we see this, there's a little bit of all of this going on in all markets. You have to stop and think about what you mean by mobility. Is mobility about being able to get a mobile device that you carry around instead of having something on the desk? That we've seen in Africa. There's a substitution effect where the individual wants communications, he gets the device because that's what he wants is mobility. But mobility is not actually about moving. It's not about traveling at a high speed in an area. It's actually about being able to register in different parts of the network. So just without going into details, let me give you a simple example. If I take a Wi-Fi card in a laptop, okay, and I travel to the other side of the planet and I switch it on there and it connects, is that mobility? Because for us, that's mobility. Let's skip that one because it's a bit complicated. Okay. Well, let's talk a bit about broadband. The relevance of broadband to this. I've spoken about core networks. We've spoken about IP. We've spoken about the convergence at that level. But there is a problem. There's a fundamental bottleneck in this network. And the fundamental bottleneck is the access to the customer. So broadband is opening that pipe to enable the customer to get access to those services. The key with a broadband network is to maximize the bandwidth and to add all of the capability into the access network to enable you to deliver to the customer. I spoke yesterday a little bit about broadband 2.0, which is really taking that one step further and giving very high bandwidth, very high quality of service to give you access to many more services, particularly those high bandwidth services that require video, for example. Let's skip this one because it's going to take too long to go through. Let's just want to talk briefly about technologies then on the access side. There is a difference. Where you have ubiquitous deployment of copper, such as in most European countries, the obvious thing to do is to use that copper to deliver broadband. But in countries such as South Africa and the rest of Africa where there isn't ubiquitous copper, there's no logic in deploying copper because it costs just as much to dig a trench and put fiber down as it does to dig a trench and put copper down, effectively. So if you're going to dig a trench, you put fiber. And so what we see in South Africa is that although there's quite a high deployment of DSL, what we're seeing going forward is the quantity of wireless and fiber is going to grow dramatically. This is independent figures again from BMIT and MyADSL. But what we do see is that in South Africa, and I think that pattern will be mirrored across Africa, is this model that works so well in the rest of the world where DSL, which is copper, and cable, which is copper, which has dominated broadband in other parts of the world, cannot dominate broadband here. We're going to see much more of two things. Fiber, for the very high bandwidth enterprise customer, the high bandwidth metropolitan user, and where you can't get to that infrastructure, it's going to be wireless. And I've indicated previously, we're deploying wireless. We're using CDMA 2000, which gives us up to, on Rev A, which is what we've deployed, 3.1 megabits per second data, combined with voice, combined with SMS. That for us is a ubiquitous net to catch subscribers outside of the fiber footprint. We are also looking at WiMAX, but for us, WiMAX is what we regard as a hot zone technology. Higher bandwidth, targeted areas, narrow areas. In very simple terms, I have yet to see a WiMAX business plan that makes any sense in anything other than the highest density city. Why WiMAX? Very simply, why would we use WiMAX and CDMA? We often ask that question. The differentiation is really around quality of service. With WiMAX, we're able to start delivering some of our enterprise services over the wireless access as well by adding quality of service. We are deploying, these are our consumer services we're launching right now on CDMA. I won't go into details to show you the picture mostly. And I said I would talk very briefly about the Electronic Communications Act. What's happened in South Africa is that we've ended up with an act which creates the model for unified licensing, creates the model for fixed mobile licensing, creates the model for unified licenses across any kind of technology. However, we are in a situation now where we're going through a transition period, and we're right in the middle of that transition period now. And as you will see in South Africa, there's the opportunity for coming up for genuine horizontal universal licenses, but it still hasn't happened because at the moment we still have mobile and fixed licenses, we still have value-added licenses and infrastructure-based licenses. There's going to be a convergence of that licensing. So projecting forward a couple of years, we will see a market where there's a very open, converged market where anybody can do anything, and then it really comes down to price and service and what you can deliver. Thank you.
Thanks.